Hi. So the next question that we have here is uh, the entire probability space, sample space, events, and probability function satisfies some axioms. Which of the following are those axioms? Okay. The first one, the probability of an event is a real number greater than or equal to zero. That's one. The probability of the entire sample space is one. Okay. If E1 and E2 are two mutually exclusive events, meaning that they have an empty intersection, and we use U to denote the union, then PE1 union E2 equals PE1 plus PE2, okay? The probability of an impossible event is always 1. Okay, so these axioms are actually called three Kolmogorov axioms of probability, which means the probability of an event is a real number greater than or equal to 0. So this is a right axiom. Okay, it can either be 0, which means the event did not occur, or more than 0, but less than 1, of course. Then the next axiom is the probability of the entire sample space is 1. Okay, total probability is 1. Again, this is an axiom. And the last one is um, the if E1 and E2 are two mutually exclusive events, they have no intersection, then the probability of their union is E1 and E2. Again, if you look into the questions, if two independent mutually exclusive events are there, then their probabilities are obviously going to be the addition. The last statement, which is the probability of an impossible event is always 0, is incorrect because the probability of impossible event is always 0. If something doesn't occur, then it's 0. I hope that makes sense. Moving to the next question, which is question 2. Consider a session of the parliament. The event that the Raj Sabha successfully passes a bill is denoted by A, and the event that the Lok Sabha successfully passes a bill is denoted by B. Suppose PA, probability of A is 10%, and probability of B is 13%, then what is the chance that either A or B occurs? So A is passing from Raj Sabha, B is passing from Lok Sabha. So I think these are the two houses of the parliament. So PA, okay, I'm sorry, PA, we know is 0.1, PB is again 0.13. Okay. Now, using inclusion and exclusion principle, so if you remember, probability of A union B is actually, unless these are two mutually exclusive, the probability of A plus probability of B in case of mutually exclusive. But because this is not mutually exclusive, you are going to subtract the intersection, which is this. So since the maximum value of PA union is when A and B are mutually exclusive, i.e., so how can we make this mutually exclusive? When PA union B, uh, when this thing is 0, okay? So the maximum value will be what? 0.1 plus 0.13 is 0.23. That's the maximum. So at most, it is going to be 23%. What if this is not the case? P minimum. We need to get P minimum. What is minimum here? This is true when the one event occur, but the other event does not occur. Which means the minimum is which has more chance of occurring here. Obviously PB, right? So we are finding max of PB, which is 0.13. So at most, at least 13%, but at most 23%. Okay? So why is that? Now, the minimum value is when one event is a subset of the other. So minimum value is maximum of probability of A and probability of B. Okay? Logically speaking, if a bill has to pass, it has to pass from A and B. Which has more chance of passing a bill? Obviously B, right? Because it's 13%. So chances of A occurring or B occurring is at least 13% and at most 23. At least 13% when B occurs and A and B both occurring is 23%. So I hope that makes sense. At least 13% and most 23%.